Hi guys, welcome back to my YouTube channel. Today we are going to solve majority element question number 169. Let's understand the question and break down the question in a simple step so we can solve it easily. Okay. The question what we are going to solve is they have given an array of size n. We have to return the majority element in the array. Basically what they are telling is see it with an example so you can understand it easily. They like I am taking one input with the length of 7. In this length I have to divide it by 2. When we divide the 7 by 2 we are getting 3. So in this input I have to check the number which is occurring more than 3 times in this array. As we can see 3 is occurring like 5 times, so we can say 3 is the output. Now we understood the question. Now we have to think how we can solve this problem. The brute force approach how we can solve this problem is we can use a hash map. Why I am telling hash map is the brute force? Because we are going to create a hash map and insert all the values into the hash map. In this case it is going to create 7 spaces. We are going to add 7 more elements into the hash map, which is going our space complexity is going to be big O of n, big O of n, which is why I am telling this is a brute force approach, and the time complexity is also going to be big O of n. Okay, now let's understand how we are going to do this. Now first we have to insert all the values into the map. I will show you how we have how the flow will be like, and then we will write the code. First I am taking 3 and I am going to insert 3 key value. As we all know, in hash map the values will be like key value pass. Key value pass. I am going to insert the key is the input array input, and the value is going to be the occurrence. If the value is new, we have to give the count is 1. If we are seeing the different value, every time the count is start with 1. If the value is occurring again coming, if we are seeing the same value, then we have to increase the count by 1. Now 4 is occurring again. Now after 3 is occurring again, and 3, 4, 5. As we can see 3 is coming 5 times and 4 is coming 2 times. Now we have inserted the values into the map. Now what we have to do, we have to check the values which has the count more than 3. For that we have to use a entry map, because in entry map only we can able to get the key and value easily without creating one more variable to get the value. Okay, now we are going to create one more loop. In that we are going to check if the value is greater than 3. If it is greater than 3 we are going to return the key. Okay, let's check the code so you can understand it better. Now here I have the code. First we are storing the length of the array in n, and we are creating the hash map. After creating the hash map we are inserting the value. How I am inserting? Map dot put of num comma map dot get or default of num comma 0 plus 1. Now we have to understand what this get or default will do. Okay, as I said earlier, like how the number is counting one by one when the value is when the value is already present in the map, by this only. When we give map dot getter default of num comma 0 plus 1, this will check whether the num value is already present in the map. If it is already present, it will increase the count by 1. If it is a new value, it will give the 0 plus 1 is going to be 1, right? So if it is if the element is new, it will be 1. If the element is already present in the map, it is going to get that value and increase it by 1. I hope now you understood why we are using this map.getter default. Okay. Once we insert the values into the map, we have to check the maximum value and we have to return the key of the maximum value. Okay. Now, as I said earlier, we have to use map.entry because in entry we can able to easily access the key and value by using the inbuilt methods and get value of get key of. Okay. And this is the enhanced for loop. The for loop, the normal for loop will look like int I equal to 0, I less than n, I plus plus. This is the normal for loop, and this one is the enhanced for loop. Here we can just initialize and provide the value here. I have entered the values in the map, right, and I am giving it here map dot entry set of. This will provide all the values to this entry. Now after this we are going to get the values from this entry map. Okay. Now I have created two variables, which is one max and majority. In this max I can have the count, which is the value, and in majority I can store the key. Okay, I am checking if the value is greater than maximum, then and I will store the maximum value to the entry dot get value of to the maximum, and majority equal to entry dot get key of. Okay, this loop will continue until it breaks, like until it comes to the last. After that, we will have the majority value in this majority variable. Once we run this, I will run and show you. We got the output, right? I will show you by submitting the code. We can see the time complexity is okay, but for space complexity you can see, right, because we are using a map and we are using entry map, we are inserting all the values to this, which will be like big O of n space complexity, which is why it is taking some time. Like it will not be an issue for like small variables, like when we work on the projects, it might not be the same, right, the values might be higher, more than lakhs or 10 lakhs. In that case we have to optimize our code. This is why we are working on these questions, so that we can solve the real time problems. We have to think in a way how we can optimize this. We have to think how we can reduce the space complexity from big O of n to big O of log n or big O of 1. Mm. For to solve this problem in an optimized way to reduce the space complexity, we are going to use one algorithm. The algorithm is Boyer-Moore voting algorithm, which is the algorithm's name. I will write it down here so you can understand it better. The algorithm's name is Boyer-Moore voting algo. algorithm. Okay, in this algorithm we can able to optimize the space complexity from big O of n to big O of 1. I will explain you the algorithm. Let's take the same input 3 comma 4 comma 4 3 comma 3 comma 3 comma 3. Okay, now the n is 7, length of this array is 7. Now what we have to find, we have to check the element which is occurring more than 3 times in the array. Now what this algorithm is telling us is we can just cancel the number one by one. Like if the first and second number is same, we are going to increment the count by 1. If we see the different number, we are going to reduce the number by 1. Like when we reaches the 0, we have to reassign the value. I will show you with an example so you can understand. I'm going to have two variables, which is count and candidate. In this candidate, I am going to store this values like 3 4 3. This is the values I am going to store in the candidate. And in count, I am going to store the count, like how many times it is occurring. Okay, now I am going to uh, start a loop. In the loop, first I am going to check if count equal to 0. If count is 0, I am going to allocate candidate equal to num of I. If count is not 0, I am going to check if the current number and candidate is same. Okay, if both are same, I am going to increment the count by 1. If both are different, I am going to decrement the number by 1. I'll show you with the example. Now since count is 0, I am going to allocate. Now let's start with index equal to 0 so we can understand easily. And num equal to 3, right? And now count is also 0. In this case, what am I going to do? I am going to allocate the candidate equal to num of 0, which is 3. And I am going to check if candidate equal to num. It's true, right? Because the candidate is 3 and num is also 3, so the condition is working. The condition is true. Now we are going to increment the count by 1. Earlier the count is 0, right? Now once we increment the count by 1, count is going to be 0 plus 1 is equal to 1. Now we are going to increment the loop, and I is going to be 1. Now what the value of count is 1. Since the count is greater than 1, it is not a 0. We are not going to change the candidate value. We are just going to check the condition, which is candidate equal to num. Here the candidate's value is 3, but the current index value, which is num's value, is 4. So the condition is false. Num is equal to false. 4 is false, right? So we are going to reduce the count by 1. Count minus 1 is going to be 0. Earlier the count is 1. Now by reducing the count by 1, we got 0. Now index is going to be 2. Count is 0. Index 2's value is 4. The count is 0. Now since the count is 0, what we are going to do? We are going to allocate candidate with the num of I value, which is 4. Now I am going to check if the candidate and num value is same. to num implies 4 equal to 4. Now we are going to increment the count by 1. Count plus 1 implies 0 plus 1 is going to be 1. I am going to increase the index I equal to 3. Now what is the count's value? 1. Now since the count is not 0, we are just going to skip that condition and we are going to the next condition. Check the next condition, which is candidate equal to num of 3. What was the value of num of 3? Which is 3, right? Now candidate's value is 4. Here this is the candidate's value, right? In the index 2 previous index. Now since the candidate value and the num is not same, what we are going to do, we are going to reduce the number by count by 1. Count minus 1 is going to be 0. Now we are going to increase the index. Index 4 is 4. Count is what? Count is 0. Since the count is 0, what we are going to do? We are going to allocate candidate with the value of index 4, which is 3. Now we are going to check the next condition, which is candidate equal to num of 4. Yeah, it is same. 3 equal to 3. Now what we are going to do, we are going to increase the count by 1, which is 1. Now we are going to the index 5. Count is what? Count is 1. Since the count is 1, we are going to skip this condition and go to the next condition, which is candidate equal to num of 5. What was the value of num of 5? It is 3. Sorry, here I kept it 3. Instead of 3, I told 4 earlier. Sorry for that. And I equal to 5 is 3. What we are going to do, 3 is equal to 3. Since both are same, we are going to increment the count by 1. Earlier it is the count is 1. Now what we are going to do, 1 plus 1 is going to be 2. Now increment the index number by 1. Now we came to the last index, which is 6, and the last index value is 3. What we are going to do, we are going to check the count is 0. Here the count is not 0, so we are going to skip that condition. We are going to move to the next condition, which is candidate equal to num of 6. Yes, candidate value is also 3 and num value is also 3. So what we are going to do, we are going to increment the count by 1, which is going to be 3. Earlier the count is 1. After incrementing it by 1, we are going to get the 3. Right now what we are going to do, we are going to print the value 3. Right, the in candidate we have 3, right? We are going to print the candidate value. This is how we have to solve the problem. This is the Boyer-Moore voting algorithm. Okay, I hope you understand this algorithm. This algorithm is simply checking, like, just think like we are having 4 numbers in an array. uh, like 4 by 2 is going to be 2, right? Like it's just don't okay, let's just take another example. We don't have to think about the length. We'll just take the number and we'll check. Okay, now here I am having 2 two twos and three different numbers. Now what will be the output? The output will obviously be 2, right? Now what I'm going to do, I am going to start, like the Boyer-Moore algorithm is telling what we have to sorry, the input has to be n by 2, more than n by 2, right? So what we are going to do, we are first going to count, take the candidate first. At first the candidate is going to be 2, right? And the count will be what? Count will be 1. Next, the since the candidate and the number is same, the count is going to increment, which is 2. Next we are coming to 3. Now the candidate is 2 and